Welcome to Competency 19 quiz. In this video, we will work with aspects of instruction. Number 1. In order to simplify the polynomial x to the 6th minus 4x to the 4th plus 3x to the 6th minus 4x to the 3rd plus 11 plus 21x to the 3rd plus 9, which of the following options is not a plausible distractor? Okay. The key to these is to look at the degrees, okay, the exponents, and what could be combined, and what is there, and what is lacking. So, what do we have here in our given? We have the exponent of 6, and I see the exponent of 4 and 3. Notice I do not see x to the first, which would just be x, or x to the second. Okay. Now I do see constants that can be combined. So you're looking at your like terms. Okay, that's the key here. All right, so now let's look at our possibilities. If you look at option A, that is your big clue. It has x to the second. Well, that is highly misleading, and it's too close to x to the third. So I would not use that as a plausible distractor. I think that it's too close to kids, panicking, seeing the 21 and the x. It's like begging the kids to get it wrong. I wouldn't use it because it wouldn't be a gauge for me because it's too easy to mistake it to the one below. Look at B. It's too easy to mistake B. Let me get rid of that because it says not. So I would go with A, not being plausible. Okay. You're not trying to trip the kids up. You're trying to see what they know or don't know. Now, if I were to like use two of them and compare and then ask questions about A and B, that would be different. Like a different situation, a different questioning style. Well, which one do you see and what's the difference between them and why would you pick one and not the other? Like one it has 20 as a constant, the other one has 2. If you wanted to compare, but that's what you're doing here. You're trying to get them to to quickly see the correct option. And gotta remember, these are young people. Okay, so I would not use A. It would not be a good distractor. Okay, now let's look at number 2. Which of the following inequalities can be used to assess a student's knowledge of solving linear inequalities in order to ensure the student's learn skills beyond the skills used in solving linear inequalities? There's a huge takeaway here. Okay, so let's look at these. This, as an educator, I would have jumped on this one inequality. And definitely with your 6th graders, when you introduce this, I would say option B. Why? Because of this -3. Look at A, C, and D. They're all showing the same thing. You're not getting anywhere. It leaves the inequality exactly the way it is. So, and we all know that if you multiply or divide an inequality by a negative, it changes the inequality. So, what you would actually have here is, of course, we all know this, it would be x greater than -5/3, which then when you go to graph it, I would also ask them to graph, it switches things around the direction of the graph. So instead of coloring everything below -5/3, you would be coloring the graph to the right instead of the left. So that goes beyond and it opens you up for the next unit or continuing on to a more complex, like instead of just the x-axis, then it opens you up for 2 variables and your entire coordinate grid and what's happening there. So that's like a segue. So, which is it's a good choice, okay? All right, so let's look at number 3. Which problem can be best used to evaluate students' understanding of the domain of a function? Okay, so remember, what is the effect or what affects domain? Well, that would be the denominator. Okay. So looking at these, that's a linear situation. So that's not going to evaluate anything. It's just all real numbers. Okay. Now, when you look at let's see, B says find the domain of this function. So I like that one because they would have to manipulate the entire equation, meaning that this would be the denominator. Then you'd have to do some manipulating to the first term, the first rational term, and go through the steps. So I would say that B would be the best. The denominator for C, where it says C, well, these are constants. That's not going to help, with, evaluating. And then that being said, well, then neither would D, obviously. Nothing is going to change. So I would say B would be your best bet. That's really going to be, they're going to have to solve like combine the two denominators from each term in B and solve through and follow through with the situation and then give you their evaluation of what the domain is. So I think B is the best choice there. Okay, let's go on to number 4. Number 4. A mathematics teacher finished a unit on adding fractions and gave a formative assessment. While grading the assessment, the teacher found that more than half of the students were making the error AC plus B over D, that would be A over C plus B over D, equals A plus B over C plus D. Which of the following is the best way for the teacher to address this error? First off, that's finding the common denominator, that's the error, which is part of the basics of adding fractions, which is an elementary skill. Okay, so what are we going to do with the students? Let's look at A. Reviewing fraction addition and give another formative assessment with questions designed to determine the common errors among the students. Okay, yes, I like that for two things. Let's look at the first one. They're going to include a review of the primary topic, which includes what the error was. Okay. And then I wouldn't say giving another exactly, which is correct. I like that. But I would call that, part of any formative. You could move on and still have it. Always include something prior that the students, as you move on, there's a big game plan that you should always be looking at. So you're going to move on. Yes, you always give another formative assessment. But in that formative assessment, you can include all of those little review items in it. And when your evaluator, your principal, your academic dean, or your instructional coach comes in, you say, oh, that's part of my grand plan. Okay, which I've, always said, hey, I get it, you know, maybe on this, could we please put in the data shows? And as a group, this is usually something you do. Or if for some reason your class is singled out, maybe you took over it, you can say, hey, for a little while, can my test have these little like one or two questions at the end? Usually everybody's on board with that. Like, okay, yeah, we get it. Your class was different, so let's give the common formative assessment, but let's add a couple on for your group. That can be done for a while, whatever. There's always a game plan that can happen. So I like A because it's flexible. I like A. And I'm going to choose it for now. But let's look at what B says. Moving to the next section in the text and including questions on fractions on the summative. Not on the summative. No, you do not wait till the end. You must attack your problems as you move on. That's what I like about A. It's such a flexible answer. Yes, I am kind of reading in between the lines for A, but it's still there for me. So let's get rid of B. Let's look at C. Asking the students to search newspapers and websites and documents on how fraction. No, yeah, right. Like they're going to know where to look and even look up the right thing. Are you trusting them when they already don't understand what's going on? Yeah, no. You cannot ask a student to do a little project on something that they didn't get in the first place. I don't like that. Sometimes you can in the beginning, or you want to, it all depends. This is not the time for a mini project, okay? Let's look at D. Moving to the next section in the text and assigning extra credit homework. Extra credit homework is something kids aren't going to do unless they're diligent anyway. And if they're diligent anyway, they probably got these questions correct. So, what you're doing is you're targeting the wrong students in your classroom. Okay, you have to make sure you're targeting the all the students. Well, this is a way to failure. It's just going to make a strong student even stronger. It's not going to lift up your students that have misconceptions. So I disagree with that. So we're going to go back to A. I think A is the best choice in this situation. So let's look at number 5. All right. So number 5 says a mathematics teacher finishes a unit on multiplying expressions with exponents and gives a formative assessment. Okay. While grading the assessment, the teacher finds that more than half of the students made an error. Okay. So what they did is they took 2 to the fourth times 2 to the fifth, and they multiplied the exponents instead of adding them. Okay, so this should have been 2 to the ninth. Okay, well, let's pop this in our calculator while we think about it. That's always a good idea. All right, so let's see what we have here. So 2 carry up to the 4 and move over, and parentheses means multiplying, so I'm going to multiply, and then 2 carry it up to the 5, and then we push enter. Well, let's do our toggle. Well, our toggle's not going to help us there, but let's put in what they put in. Okay. All right. So 2 carry it up. They said 20. Well, obviously not. Well, let's take and add those exponents together, which would be correct. So 2 carry it up to the 8 and see what we get. We get the correct answer. So it's a difference between knowing the laws of exponents, okay? So let's see which one of these gives us that way to get the students on board. Let's see. A says the students multiplied. It says which of the following is the best description of the arrow. So we're just trying to describe the arrow. Okay, fine. The students multiplied the exponents instead of adding up. Well, that's what we just proved they did with our calculator. Okay. And if you, this is a good way that if you get confused during the test on what you should know, you get tired and you're like, what was the mistake? Well, put in what you know into the calculator like we did just now. And this is obviously you see what happened. Okay. The students should have expanded. Okay. And then multiply the numbers instead of using the properties of exponents? I don't think so. That's not the best description of the error. Yes, it's a way that the student could have gotten there because let's multiply 16 and 32. 16 times 32. Yeah, but that's one way to get there, but it isn't the error actually shown right here. This is not what the error shows. That's a process, but not an error. Okay, so I disagree with B. Let's look at D. The student should not have omitted the multiplication sign between the two numbers and oh, no, 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 that's not it. That's not even a rule. Okay, let's see D. The student should have expanded the answer 2 to the 20 to an integer. No, that's not going to help. That isn't the error. It would have helped the student see what happened, that they were wrong, but it doesn't explain the actual error. Okay. All right. So option A is what we need. So let's go to number 6. Number 6. Which problem can be used in an informative quiz? Okay. Let's look at each of the options. A. Solve the equation x squared minus 5x plus 3 equals 0. We're looking at something just to inform. Well, the student could do a lot of this is just like, can the student solve this? It doesn't give you more information. Okay, so let's look at B. What is the solution for the equation? Well, that's just the same as A. It's just worded another way. So I don't like that question. Let's look at C. Solve the equation. Well, this adds a little more to the process because they would have to create a zero pair with the 4x. But it's still pretty much the same as A and B, which I don't think really gives that informative uh, information that you need. Well, let's look at D. Given a x squared plus bx plus c, which is standard form, equals 0, what are the values of a, b, c in the equation? And it is the same type of quadratic. So all of your options. Now, wait a second. If you look at c, that's not a quadratic. So I don't like C because that's just combining like terms, and then it's going to be linear, and it says which would be informative. So this is just there's a lot of ways to solve this, and they could use their calculator to do it at this point, depending the grade level. But really, if you're trying to see if they understand the setup, which would be informative to get to the next step to solve and not just solve. D is actually your best choice because what are the values of A, B, and C? So you're not wondering if they can solve, you just want to know if they know the information incorrectly. So they're going to know that they're just going to identify a is 1, B is -9, and C is the constant, which is positive 44. That is an informative quiz. Unlike the others, which would be, just think about it, A, B, and C, or would not be informative. That would be more of a summative because it's asking for you to solve. So that is assuming that the student has learned everything that they need to know and they can go ahead and give you some sort of a solution at the end. So that's what's wrong with A, B, and C. They're looking for the end result, whereas D is asking a student to answer something that would be along in the process of learning how to solve. Okay. I know that was long winded, but that's basically what's going on with that question. So let's look at number 7. When assessing students' knowledge of linear functions, which of the following notions should be the core point? Okay, let's look at A. The concept of the coordinate plane. It says assessing their knowledge of linear functions. No, because you could put any function can be put on the coordinate plane. So, and it'd be plotting. So it doesn't say anything about plotting. So I don't think A is a good choice. Let's look at B. The concept of graphing and plotting, chord and plane, that's all about the same. It's in the same thing, so I don't see that. Let's look at C. The concept of solving a system of linear equations, that's a totally different topic. It involves linear functions, but it's a different topic. So I don't like that one. Cross your fingers on D here. I hope it's it. D, the concept of modeling paired data. Yes, I like that because when you're talking about linear functions, you're going to start talking about best fit, and you're going to linear regression, and also what are the answers when you solve them. You actually solve, you have an X and a Y, and they're specific, because it is a straight line. So on that line, you would have paired points, and that's how we determine the values, that the quote unquote solution set, all those things. So I'm going to go with D here. Okay, just because it just makes the most sense. All right, so let's look at number 8. After grading your students' exams, you notice that many of your students draw the conclusion 3x equals 11y from the series of equations. Okay, so if we start here in this situation and we start here, okay, I got that. So you're going to start the students from here. But then the student says this equals 0. Well, unfortunately, that's a fallacy. And it's a fallacy because in order to get 3x equals 11y, we would have to divide by 0. You would apply the cancellation rule at this juncture right here. You would have to apply canceling. And when you do that, you're canceling 0, which means you're dividing by 0. We can't do that. It is not mathematically valid to divide. We can multiply by 0, but we cannot divide by 0. Okay? This error among your students is an indication of what type of mathematical misconception. I just said it. I see it. It's number C, division by 0. It simply isn't allowed. Now, your 0 can be part of the numerator, but it is not valid to be the denominator, okay? All right, so this is the last question in this video and this section. I wanted to thank you for liking, sharing, and subscribing. It is greatly appreciated. And I wanted again give a shout out to all of those subscribers who are supporting us, and also to those of you who actually said you passed your test. Kudos to you. And once again, I would like to wish everyone happy testing.